introduced how to create a generating function for certain sequences. In this video, we'll continue that lecture and discuss how to create generating functions for more sophisticated sequences. All right, what about the sequence 2, 4, 10, 28, 82? Let's see, so 2, 4, 10, 28, 82. Here the terms are always one more than the powers of 3. That is, we, in this case, just add the sequences 1, 1, 1, 1, 1 with the powers of 3, which are 1, 3, 9, 27, 81, and so forth. And then you do this term by term. Therefore, we can get a generating function by adding the respective generating functions 2 plus 4x plus 10x squared plus 28x cubed plus and so forth. And then this is going to equal 1 plus 1 plus 1 plus 3 x plus 1 plus 9 x squared plus 1 plus 27 x cubed and so forth. So by the way, this is equal to 1 plus x plus x squared plus x cubed plus and so forth plus 1 plus 3x plus 9x squared plus 27x cubed and so forth. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below and make sure to click on that subscribe button. The fun doesn't stop here though. If you replace x in our original generating function by x squared, we get that, and I'm going to clear some room for this one, we get that 1 over 1 minus x squared equals 1 plus x squared plus x to the 4th plus x to the 6th and so forth, which generates the sequence 1, 0, 1, 0, 1, 0, and so forth, because in this instance there are no x terms or x cubed terms or x to the 5th terms. So how could we get the sequence 0, 1, 0, 1, 0, 1, and so forth when we know the generating function for that sequence? Well, start with the previous sequence here, that one with the arrow, and shift it over by 1. To see how shifting works, let's first try to get the generating function for the sequence 0, 1, 3, 9, 27. We know at this point that 1 over 1 minus 3x is just, the generating series here is 1 plus 3x plus 9x squared plus 27x cubed and so forth. To get the 0 out front, we need the generating series to look something like x plus 3x squared plus 9x cubed plus 27x to the 4th and so on. So there is no constant term in this one. Multiplying by x can do just that. So the generating function for this sequence is x divided by 1 minus x, or because in this case by multiplying by x, that shifts the entire sequence down by 1 and throws a constant term of 0 at the very front here. So if we want to stick a 0 in front and shift everything over, we just need to multiply by x. So this will also work to get the generating function for 0, 1, 0, 1, 0, 1, and so forth. So we just have to multiply by x, which means that this sequence is generated by the function x over 1 minus x squared, which is that function multiplied by x. So what if we add the sequences 1, 0, 1, 0, 1, 0, this one right here, and this sequence right here? Well, if we add those two sequences, we would get just the constant sequence 1, 1, 1, 1, 1, 1, 1. Well, what happens when you add these two generating functions together? Well, we should get the generating function for this sequence 1, 1, 1, 1, 1, and it actually works. And you can try this. So if you, they have common denominators, and so you can add the two, and that will allow you to cancel a term with the numerator and denominator, and you'll get 1 over 1 minus x. So this math works out. Here's a sneaky one, though. What happens if you take the derivative of 1 over 1 minus x? Well, let's take a look. So if we take the derivative of this, we get 1 over 1 minus x all squared. On the other hand, if we didn't differentiate term by term in the power series, so the power series for this is, again, 1 plus x squared plus x cubed, and so forth. If we differentiate these term by term, we get 0 plus 1 plus 2x plus 3x squared plus 4x cubed, and so forth. Which is, by the way, the generating series for the sequence. In this case, it would be 1. Don't forget, 0 plus 1 is 1. 1, 2, 3, 4, and so forth. So what this all means is... Oh, I got to clear this first. This means that the generating function for 1, 2, 3, 4, 5 is 1 over 1 minus x all squared. Well, let's take the second derivative of that function. So the second derivative would be 2 over 1 minus x all cubed, which, by the way, is 2 plus 6x plus 12x squared. Again, differentiating term by term, plus 20x cubed. And then I think the next one, I don't know the next one. But anyways, you get the point. So that means that 1 over 1 minus x cubed, if we were to divide each term by 2 here, is just 1 plus 3x plus 6x squared plus 10x cubed, and so forth. It's a generating function for the triangle members, which is, this generates the sequence 1, 3, 6, 10. Although here, technically, we have that A0 is 1, but with the triangle numbers, T0 is 0 usually. Anyways, thanks everyone, and I'll see you in the next video.